As well as being protected with fuses or circuit breakers, electrical systems are commonly fitted with residual current devices or RCDs. Fuses and circuit breakers serve mainly to protect leads and cables from overload caused by short circuits and ground faults. Residual current devices, on the other hand, protect people from electric shock when they come directly or indirectly in contact with a live conductor. They also provide increased fire and system protection. They work by detecting residual current flowing to ground, for example, caused by an insulation fault, and switching off the defective circuit before it can present a risk to people. According to European standards, every final circuit must be protected by an RCD with a rated residual operating current not exceeding 30 mA. For distribution boards, this means all 230-volt socket outlets, as well as any 16 and 32 ampere 400-volt outlets that are used for operating end consumers. The snag is that an RCD cannot distinguish between the capacitive leakage currents that occur in normal operation and are caused by the capacitance of lines and filters on one hand and dangerous resistive or ohmic fault currents on the other. Nearly all electronic devices, as well as equipment operated with ballast devices, causes capacitive leakage current. Additional ground leakage is caused by the capacitance of lines and by the line filters needed to fulfill the requirements for electromagnetic compatibility, or EMC. Especially frequency converters, which are required to operate motors efficiently, generate high leakage currents. The total of all leakage currents can cause the residual current device to trip, thereby switching off all consumers connected to the affected line. In the entertainment industry, an unwanted switch-off of a power outlet can have serious and costly consequences. At INDU-ELECTRIC, we recommend to individually protect each socket outlet with an RCBO, a residual current-operated circuit breaker with integrated overcurrent protection, with a tripping current of 30 mA. According to harmonized Senelec standard HD 384.7.711, which applies in most European countries, all cables and lines intended for supplying temporary structures must, in addition to having personnel protection, be protected with residual current devices, with a residual current rating of 300 mA. The RCDs that we use for this purpose are residual current monitors, or RCMs, from Bender. These RCMs have the purpose of ensuring an efficient and reliable operation of the system and will physically display accumulated leakage and fault currents during operation. So, what are the ideal settings for the RCMs? To help us answer this question, we first want to explain a couple of terms: leakage current and fault current. What exactly is leakage current? Leakage current in this context is an electric current that leaks out of the intended circuit into some other path under normal operating conditions. This leakage is of course undesirable. Even fault-free electrical devices induce a leakage current in the system into which they are incorporated. There are three types of leakage current: stationary, dynamic, and transient. Stationary leakage current. Stationary leakage current is current that flows to ground or to some other conductive component in a fault-free circuit. This current is generated by capacitors in EMC filters and the capacitance of long shielded cables, and can therefore have a capacitive component. Chargers for laptops or mobile phones are a great example to illustrate normal leakage current. Up to 4 mA leakage current may occur depending on the manufacturer of the charger. Dynamic leakage current. Dynamic leakage currents occur, in particular, when switching devices with interference suppression filters. They generally have a duration of a few micro or milliseconds and can have a magnitude of several amperes. Transient leakage current. Switching a circuit in stage lighting systems with many lamps can in addition cause transient leakage current. Depending on the phase angle, switching on a circuit results in rapidly rising voltage peaks. Because of the circuit's inductance, the same happens when switching off the circuit. Through the filter capacitors of the ballast devices, these sudden voltage peaks create a transient ground leakage current, which can cause the residual current device to trip when the system is first switched on. Let's now take a look at fault current. Fault current is current that flows back to ground outside the actual live conductors due to an insulation fault. If, for example, a person comes in direct contact with a live conductor, a ground fault current occurs. The connected RCD detects this fault current and immediately interrupts the circuit. Unlike the mainly capacitive leakage currents, fault currents of this kind usually have a high resistive component. The RCD cannot, however, distinguish between the different ground currents and will trip as soon as the sum of all leakage currents exceeds the tripping threshold. As we already mentioned, this is quite possible even under normal fault-free operating conditions. In stage systems, the leakage currents can amount to between 1 and 4% of the system's rated current, even in a fault-free installation. We hope that all the fundamental definitions have been understood well enough in order to proceed with the actual settings of the RCD. Adjustable residual current monitors have proven to be a reliable line protection solution. For our power distribution boxes, we are using the Bender Residual Current Monitor RCM420. It reliably protects the installation from these unwanted power outages. In addition, its built-in display indicates the sum of all fault and leakage currents within the entire installation. Suitable threshold values for any given event can be easily set on site. The required value is found through vector addition of the installation's measured inherent leakage current, for example 670 mA, and the RCD tripping threshold specified by the applicable regulation, for example 300 mA for system protection, yielding in this case the practical threshold value of 970 mA. With the setting, the RCM in effect ignores the system's inherent background leakage, tripping only when the additional leakage current, i.e. the actual fault current, exceeds the background leakage by 300 mA. In addition to measuring leakage current manually, we will look at how to do this in a minute. You can leave this task to the Bender RCM. The display of the Bender RCM provides a precise indication of all leakage and fault currents that can cause the RCM to trip, from 50 or 60 Hz currents up to 2000 Hz. If the RCM trips because of a ground fault, the indication of the total tripping value makes troubleshooting much easier. So, how do we measure leakage current? Measuring leakage current in an installation is easy. You simply measure the current in the protective conductor with a clamp-on ammeter, as shown here. Keep in mind that most clamp-on ammeters indicate only 50 or 60 Hz current. You should therefore use a true RMS clamp-on ammeter, which is capable of measuring also high-frequency fault currents of up to at least 10 kHz. It is required to measure the leakage current at various operating modes. Especially monitor consoles in the reporter cabins and electronically controlled air conditioners and heaters have a decisive impact on the total leakage current. Experience has shown that the leakage currents vary from event to event, and that it does not therefore make sense to recommend generally applicable threshold settings. You must determine the leakage current in each case and adjust the RCM accordingly. Keep in mind that, especially around the intermediate and main distribution boards, the leakage current can add up to anywhere between 1 and 4% rated current. We are now at the end of our session and hope that we were able to give you a better understanding of earth leakage protection and how to adjust the RCD monitors accordingly to each individual field setup. Please remember that each field application is unique and will require individual settings that need to be determined. Thank you very much for your loyalty and for being a valuable customer.